Next thing on my fabulous to-do list is adding invert polarity parameters and phase offset parameters to everything that has something like an LFO that can be free or tempo sync. I guess it would not make sense for the Perlin noise modulator because it's very random, and I'm even thinking of ditching the tempo sync feature for that modulator. But the randomizer that can be very edgy should have at least the offset. Yeah, the polarity parameter would be pointless for that thing either, but the LFO should definitely have both of these. Now I just have to remember how did it work to add a parameter to my modular system. I have not done that for a while now, so it's going to be interesting. I guess a nice way to start this journey is to go into my parameter header file, where all the parameters are created in the juice way, and for each of my two modulator components I have instantiated all of the possible parameters. So if I wanted to add something to the LFO, I would just go here and say LFO phase 1 and LFO polarity 1. Yeah, so polarity and phase for the LFO. In my create parameters function, something that a lot of juice developers know and have, I go to the place where I create my LFO stuff, and now I add stuff that is needed for the phase and polarity. It must be in the same order as my IDs. So polarity phase comes after wavetable. Wavetable, polarity, and phase. Polarity can be either 1 or 0. For the polarity I need a parameter bool. Create pbool. Yeah, that sounds nice. And then the ID, default value. Okay, the default value of my polarity flip is false. And then the string thing that is used, polarity string, that's something that I still have to make. And now the phase rotation parameter, kind of arguments to have here. Default value, it's just 0. When people want to dial in a phase offset, they should do it themselves. And the next argument is I have to define a phase string. Now I have to make sure that these things exist. Up here I have all my string lambdas. So const auto polarity string. It is the string that defines how things are being drawn to the screen when the parameter value matters. For example, in my pop-up component, but also in the door itself, when the door has a feature where it shows the value of the parameter and stuff. Return juice string. So these are the string returning lambdas for these two parameters. What I put in there I will decide later, but first of all I will make sure that I also create these for the second modulator. Now value is smaller than 0.5, in which case off, and else it is on. My cat is meowing at me. Kleine Katze. And now the phase value, considering phase is something that goes from 0 to 1, we would want to display this as a degrees value, because people who make music usually don't know about radians, even though it would look cool and scientific to actually use radians. Maybe I will do that later. And then we floor the value so that it looks cooler. And then we also add the official degrees symbol. I wonder if it would make sense to add polarity to this sentence. Yeah, well, we can tweak these later. So now we have made the parameters, and I just have to make sure that everything makes sense in plugin processor. I have this huge vector, all parameters. I'm not even sure if I'm using that at the moment, but I have. And until I have investigated into this comment, I will just have to add stuff here and hope that it was worth it. So polarity and phase. Great, so let's see where we have to add this stuff. I'm activating parameters for on my metrics, only parameters that don't belong to any modulator. Then activate the macro modulators and their parameters. And then I make the wavetables for the LFOs, and I initialize all the modulators and the parameters. And I think this is where things will get interesting again, because obviously now we have to add more parameters. Now obviously it does not like that, and that's because obviously I have not adjusted these methods to want more parameters yet, and I will just do that now by going into my modular system down to the method for creating LFO modulators, and there I add the new arguments, the Polarity PID and Phase PID. Now I just have to do the same thing that I did with the other things. I have to make a polarity parameter and a phase parameter by giving it the polarity PID and the phase PID. This is, by the way, a shared pointer parameter of my modulation system. Now I can give the polarity P and the phase P to my newly created LFO modulator. I need to attach the parameter to it. Now the next thing is that the LFO modulator currently does not expect all these parameters. So we yet again have to go somewhere and change a constructor list. The one of the LFO modulator will now expect some more parameters in here. One of them, the polarity param, and the other one, the phase param. And now that this is the thing, I can add the parameters to my params vector. Every modulator has a parameters vector that is important for things like when a modulator modulates another modulator and then that other modulator tries to modulate parameters of the one modulator, which is a paradoxon obviously, but what do you want to happen if a user tries that? Do you want the program to crash? For example, if you do that in FabFilter Saturn, then there will be a little error message popping up telling you that this makes no sense, and then you have the option to just remove the modulation again. But my approach is that it will automatically remove the old modulations that don't make sense anymore and rather work with the new ones. I'm not sure if that makes sense yet, but I think if people focus on their sound design in a way that they really want to add this modulation now, they definitely don't care about the old modulations anymore. So now I added these parameters and they obviously exist now, so I can go ahead and use them. The phase flip one is the easiest. I just have to say const float polarity params of polarity get smaller than 0.5, just like the sync. And yeah, the polarity word does not exist yet in this enum. Great. Now I can use the polarity value, which will be, if it's below 0.5, so that polarity invert is off, so it's 1, and else it is -1, so that when we multiply this with the signal, we get a polarity inversion. Now we can multiply the polarity value with the signal, or actually we can even use a float vector operation for that, because we know there's a nice float vector operation for multiplying something with a value. Our destination block, multiplier, and num samples. I'm just wondering if polarity value is 1, if we should even do this. I will do it differently. If polarity flipped great, that looks really clean. Now we need to add the phase offset. So in our process phase, we will just get the current phase offset. And I will do it on a sample-based manner, because it might be that people want to modulate that. We know that the phase value is something between 0 and 1. So we add with offset is phase plus phase val, with offset being smaller than 1, then with offset, and else with offset -1. Great, that should do the trick, I think. Now it makes sense to test it. However, there are no parameters on the UI yet for accessing these kind of things. So the LFO component has a bunch of member variables and it will now need another one. First of all, it needs a switch for the polarity and then a modulatable knob for the phase. So the phase comes after the width thing. This is the tooltip text. I don't want to make a text now. And now the same for the polarity. Now I have to make sure that it all works very nicely. The modulatable parameters now have another parameter that can be modulated, which is the phase. The randomizer can randomize even more stuff, the polarity and the phase. When the setActive method is called and when all the parameters are initialized, the top level component adds these two. This might look weird, but it's important because I'm actually drawing all of my parameters on the top layer in order to get some layout benefits with the layout class that I wrote. I have to make new space for parameters. If the project now builds, I can just check out what it's currently doing. So apparently there is an issue on my parameter creation into the AudioProcessorValueTreeState. I completely forgot that for each parameter I need to implement this method, which gets the name of the parameter. And now stuff works again and I can check out my layout. So what we can see here is there is a margin of 30 at the beginning, then there is 50 width for this parameter, then there is 90 width for the middle parameter, and then there is 50 for the last one as well. And now if we wanted to add more parameters, we would also have to give them a width. Maybe the phase one can be even smaller than that. And we'll just put the polarity one below the phase one, because people always think that phase and polarity belong together. So we let our layout place the phase next to the width, and we let our layout place the polarity below this parameter. Yes, now we have, okay, it seems to not make sense to draw such a big string in here. The string lambda for the phase does not draw the degree symbol correctly, but at least everything seems to work fine. However, it looks like it actually does not work fine. Changing the phase seems to look like it's working, but turning polarity on just makes something very weird with the signal. The modulator signal is not a signal that goes between -1 and 1. It actually goes between 0 and 1. Let's just ditch the float vector operation here and rather do it the traditional way that our grandfathers also did by using simple math. This should work. Great, so now that this seems to work, we can finally check out how it sounds. Yeah, this is really cool. I just noticed that the waveform editor does not repaint on the randomizer trigger. I will have to fix that. But enough of this video.